My name is Yingro Zhao. I'm a Python engineer from Axial. I have about 4 years experience working with Python, and my recent focus is on the web development and the search. Briefly about the company Axial, we are an online business development platform that match investor, buyers, advisors, and to the private company owners. Our goal is to help business to close more deals on our network. A typical use of our network would be an investor come to our website, put down a search criteria, their target range of the industry, the revenue range or location information, and they will get a list of companies that are either for sale or for financing opportunities. They can start from there and connect with the business owners and potentially close a deal. We use Xapian to build our search engine. It's a core functionality in our application. So what is Xapian? Xapian is an open source search engine library. It's released under GPL license. It supports high efficient. It is a high efficient search engine. Supports search of large volumes of unstructured text. We can do query faceting, Boolean filter, very easy with Xapian. Xapian is written in C++, but it has a good Python binding. It's very small. It has very small footprint. With all the dependency and its Python binding, the size of Xapian is around 30 megabytes, and it requires minimum dependency to set up to add your application. It's very portable. Xapian has support multiple languages, including Perl, Python, C#, Java, Node.js, and many more. And it's cross-platform OS, so we can install Xapian to Linux, Mac OS, and Windows. Before we go to details about Xapian, let's first look at a basic of search. So there are two important steps about search. First one is the indexing process. We need to build an indexer in a database from the source documents. Usually we use an indexer to parse the source and build the database. Once the database is built, we can make queries to the database. The user, typically, a user will have an input query string, and it's parsed by a query parser into a structured query and perform a search against the database. It will get a list of results, and we will apply a ranking algorithm so that the result is sorted on how relevant the result to the query. So how we index the data has great impact on the search performance. In Xapian, a unit of data model is called a Xapian document. So it contains all the information needed to perform the search. And a Xapian database is a collection of documents. So there are 4 key elements in each document. So the first one is the unique 32-bit integer to distinguish between each document. And it contains a list of terms. So terms are the keywords that we parse the original data. So we use term to get a match and query the database. Values is another format of term, but it's in serialized format, and it's usually used to doing range query, sorting, and faceting. Xapian also allows us to store a arbitrary data inside the document. This doesn't have impact on the search, but it's for storage purpose. When we retrieve the data, we can display the data easily with this data blob. The recent release of Xapian uses this chart backend. It's how we organize the tables in the physical disk. And the data is compressed, and it supports atomic modification, means you can either successfully update the database or failed. You cannot in middle of the transaction. It's a high-performance database with this single writer, multiple reader access model. At one time, there is only one writer can update the database, but there are multiple readers can access the database at the same time. And Xapian also provide this DAW tool to help us easily inspect the database. We will demonstrate that in the later demo session. So I built this application for the demo using this IMDb top 250 movie ranking. The data is gathered from the IMDb website. For each movie, we picked several fields to index for simplicity. So we can gather data from this API, and the data is in JSON format. So we're interested in the title, the release year, and the movie's rating, and the plot, which is unstructured text, and the names of the directors and the stars. So we want to build the search so that it supports not only a keyword search, but also we can search a title that if a keyword only exists in the title. And we want to support range query on the year, released year. And the rating, we can do a facet on the rating. For example, we get a list of results, 10 movies. How many of them are rated PG or PG-13? We can support that also. The first step is to index the terms. So index term is the process of parsing a block of text into individual keywords. For example, the text, origin text, green tea, ice cream. After the index, it will become a list of terms in lowercase and stored in the Xapian document. When we parse this string, we also store how frequent a term occurred and the positional information. The reason for that is to support the weighting and a phrase query, because we know which word occurred first and the order of the terms. So while we index terms, we usually use a stemming normalization logic. So the stemming is to reduce inflected or derived word into their root. So in English, we have a word root like this, connect. It can have different format. So for example, this connected, connection, connecting, and the connective can all derive to the root connect. And we want to store the root term so that all this, when we search this keyword, it will match connect. So in Xapian, we can do that. We store this connect with a prefix z, which indicates this term is a stemmed term. Xapian actually supports 15 different languages for stemming. We can also optionally add a prefix to a term. So the prefix is a uppercase letter in front of a term. It is to determine which field this term originated from in the source data. Like, for example, the title of the movie. If we want to if you add a prefix s in front of the title, we are able, in the search time, we are able to tell, we are able to search specifically this movie contains the keyword, but only in the movie's title field. In Xapian, we have this convention to add the prefix. So for author, we use A, ID, we use Q, title, we use S, and for user-defined, we use X. So here is how we use Xapian term generator to index plain text or index a term that with prefix. First, we instantiate an object of term generator. We set the stemming to English, and we create a new Xapian document object called xdoc. We set the xdoc to the indexer. Then we can just use index text and providing a unstructured text. Xapian will parse this and generate a list of terms. If we want to add a prefix, we can just add additional arguments, and it will index this the title with prefix. So now we have the term being indexed. We can add values. So remember, we mentioned the value is to support, usually it's a number or a date that we put into a slot in the document. Value are in the binary string format. To add a value, we just need to call the add value method on the xdoc object. We provide which slot, we tell Xapian which slot we want to add the value. We can add many values. Here, we are interested in doing the range query. So this year, we will, because it's a number and we want to support range query, we use this sortable serialized method to serialize this number. For the movie's rating, we just put the string directly to the slot. So now we have terms and values added to the document. We want to add the data blob so that in the query time we can display the JSON, original JSON format data. We use this set data and dump the JSON into string. And in the end, we want to write into the Xapian database for this document, this movie. So we call the replace document. What this does is, if there is existing document with this ID, it will update. Otherwise, this will insert a new document to the database. So now we have, we run this for each movie and we build the database. And now we can make some queries onto the database. Xapian also provided this query object. So in Xapian, there are two kinds of query: simple query and a compound query. A simple query is can be a keyword, a term, or a value that you search a certain range of a number. Compound query is we can join two queries in Xapian with a query operator. So in this case, we call the queries constructor in Xapian, providing which operator and the two queries. Xapian will produce a query, a compound query for us. These are the common Xapian operators Xapian support. They are logic operators like op and, op or, op and not. Filtering operator, op filter. The difference is for filter is the weighting. It only calculates on the left side of the operator. Value range operator, less than, greater than, and range. And the phrase operator, that we can search a phrase. this is how we use Xapian query parser. So this is useful when we want to convert a human readable string into Xapian query. First, we set up the query parser, set the stemming, tell it where is the Xapian database, and we can start using this parse query method and providing just a string. Xapian knows how to interpret a keyword or the symbol of this operator into query operator. So the output is something like a term and the position with operator or for this plus sign and not for not. So what if we want to search the movies released from 2010 to 2015? We already indexed the movie release year into the slot, and we can use the query parser to construct a query. To do that, we just need to add a value range processor to the query parser. We tell this is a number value range processor, so it will search on the number, and it's on the slot, the slot of the year. So that now we can input this string 2010 ... and 2015. This will construct the query, year range query for us. Here is how we get the result from Xapian. So now we have Xapian use this enquire object. So we we first instantiate a enquire object, set the query that we want to query the database, and use get match set, providing a size of how many results we want to match. So this will return a Python iterable, and we can print the result, the documents, so that we see the result. Lastly, let's look at the result faceting. So sometimes it's useful, like when we get the results, we want to show some faceting information. In this case, we want to show how many movies rating, the counts of the movies rating in the result set. We can do that by using a object called a spy in Xapian. The spy we can think about is an inspector onto a numbered slot. It has the ability to inspect many results at once with very high performance. It's kind of like the SQL query, we use a group by. So we get the spy object, we add the spy to the enquire object, and we can use spy.values. It will show us all the counting information for movies rating. So now let's look at the demo. So first, I want to remove the Xapian database so that we can run a new index process. So we use this index.py. So it first fetch the data, the JSON data from the remote API, and then parse it and build the local Xapian database for us. It's finished. We can take a look of the database that we built. It contains several files that needed to perform query. We can even use the DOV to inspect the database and getting some statistics. So this shows us there are total 250 documents, 200 corresponding to 250 movies. The average length of the document, it has positional information, which means we can make freeze query. All right, so now we have the database. We can use the query.py to make a simple keyword query. Let's search the keyword dream, see what we get. So it prints, show the documents of the movie in the JSON format, and all this get matched because it has a term of dream. So that's easy. Let's say we want to search that movie's title, that only movie's title contain the word dream. So we can do that because since we already indexed the title with a prefix X, so this query will get the match only that this movie has a keyword dream. So let's take a look of a keyword query together with year range. So let's say we want to get the movie that has term love, but also want to restrict the release the year from 1990 to 1995. We can do this. Oh, I missed a dot. So this will construct these two queries, combine these queries together with the filter operator, and it shows us this movie, Forrest Gump, that match our search criteria. Okay, lastly, we can do something. We can search the movie that, all the movie directed by Steven Spielberg, and show the facets on the movie's rating. So we can do this. So we get totally, these are the movie results, and we get totally 7 movies, and the facets information tells us there are 2 rated PG, 2 rated PG-13, and 3 rated restricted. So that's the faceting. All right, that's about my, yeah. Oh, yeah. So this is the demo. So I made the code is easier to understand, so I encourage everyone to check out the code and walk through the code, so you can understand Xapian better with the code sample. Any questions? Yeah.
How well does this support searching over like a more complicated character sets, like the CJKB character set? Or does it only work best like with ASCII, or will it handle like the full range of Unicode characters?
Xapian supports full range Unicode. When you index it, you tell Xapian you index a Unicode string. It will store that in Unicode. Yeah. Sure.
What kind of performance have you seen on like really large data sets using Xapian?
For our application, we have about 20,000 companies that we indexed, and we make queries, simple queries, and faceting and filter on that. We see it's performing really well. We haven't done much performance benchmarking yet, but for our application, it is really good. Yeah. Any other questions? Does what? Caching the results. Xapian doesn't cache the result for you, but you can write your own code to cache the result. Yeah, it's just the search library that you can use. Okay, all right, thank you.